The last thing I want to talk about today is something called converses. We notice consistent patterns between specific angle relationships when we have two parallel lines cut by a transversal. The key component was those two parallel lines. We can use this thinking in reverse, and in math we call that thinking in reverse converse. Consider this. If I say we have parallel lines L and P, so those two lines, and oops, I'm going to mark them as, that's not the right tool I want to use. I want to use this tool. Mark those as parallel by doing those arrows. If I say that I have parallel lines L and P cut by transversal Z, what conclusions can I make about each of the following angle relationships? So angle 1 and 6, angle 1 is here, angle 6 is there. Well, we know from our practices today that those are corresponding angles. So they are, let's write this a little neater, corresponding. But the conclusion I can make is that those corresponding angles are congruent. So angle 1 is congruent to angle 6. How about angle 4 and angle 6? Well, let's see. Angle 4 is here and angle 6 is there. Those are same side interior angles. And the conclusion we can make, because they're two parallel lines cut by a transversal, that angle 4 plus, well, technically it's measure of angle 4 plus the measure of angle 6 equals 180 degrees, because same side interior angles are supplementary. And lastly, angles 4 and 5, I'm going to erase some of this to help us with our thinking. So angles 4 and 5, if I know that we have two parallel lines cut by transversal, 4 and 5 are alternate interior angles, alternate interior angles. So that means they are congruent. Angle 4 is congruent to angle 5. So we know all of those things, and we could come up with a few more angle relationships. But what if I went in reverse? What if I just said that we have lines L and P cut by line Z, but I also said angle 1 was congruent to angle 6? What could we conclude? So if I had the exact opposite situation, if I had those two lines, L and P cut by Z, and I said that angle 1 was congruent to angle 6, what conclusion could I draw? Well, if those two angles are congruent, those are corresponding angles. So the conclusion that we could draw, the thing that we could say is, because those angles are congruent, angle 1 is congruent to angle 6, and they are corresponding angles. Oh, I'll make that look a little neater. Corresponding angles, comma. Then that means those lines are parallel. L is parallel to P. It's the exact reverse. If I know that those two angles are congruent, and we've got two lines cut by a transversal, if those two corresponding angles are congruent, that means those lines have to be parallel. So we can make the exact opposite conclusions. If you're given a diagram and you have the corresponding angles are congruent, or the alternate interior angles are congruent, or all the other relationships we've covered today, then that proves those lines are parallel. It's the converse.